Alright, so here are our different figures. We'll start out from smallest to largest. We've got cutting off a ½ inch. This was our figure, and 37.5 inches cubed. Cutting off an inch, which is probably this one.
That's 2
inches. This is 2 inches. There, oh, you guys are an inch. Never mind. Inch, they say, is 58.5. Inch and a half was 66 inches cubed. Next is 2, so this was 2 right here, and it was 63 inches cubed. 2.5, which is right here, which is 52.5, and then 3, which is right here, and it's 37.5 inches cubed. Zach, I gave you tape. Just stop. We're moving on from it. You had your opportunity, and you
messed it up a little bit.
Screwed it up. That's for sure. All right. So it appears that our maximum volume is going to occur when the amount we cut off is located where? It looks like 1.5, but am I guaranteed 1.5 to be my max? No. So what does it need to be between? Yeah, all right. Somewhere it could be in there, and it could be in there. How can it be here when I have 66 there and I have 63 there? How can it be between 1.5 and 2 if it went down in between those two? Somebody answer that question for me. I'm saying, how can the maximum occur in here when I went from 66 to 63?
Because it goes down, then or it goes up and then it goes down, and so it could still be increasing there. And then go
All right, good. So we could go higher than 66 past an inch and a half and then come back down to 63 is what I wanted to make sure you guys are understanding. You with me?
Are you saying so it could be 68 somewhere in there and then just go back down to 63?
Correct. That's what I'm saying. Okay? So the same thing in here. We could go past 66 and then start coming back down. So it's got to be either between an inch and an inch and a half or between an inch and a half or 2. Okay? So now we want to use calculus, hopefully we have time, to figure out how much do we really need to cut off to find our maximum volume. Okay? So how did you guys find the volume of this? All right, so we'll start off with volume equals length times width times height. All right, then what'd you do?
He found the length of the height times the dimensions of the first cut off.
All right, so the amount I had you cut off, what did that end up being?
Height.
That ended up being the height. So this was my h. Okay, that ended up being my height. All right, so how can I find the width and the length knowing my height? What did you guys do? All right, so I take each of these sides and then subtract it. So my length ended up being 11 minus 2h, and my width ended up being 8.5 minus 2h. Okay? So because I have these formulas written here, what can I go back and do to my original? I can substitute them in. So I have V equals 11 minus 2h. And then I have my width is 8.5 minus 2h, and then I have h. Okay? Now what do you think we want to do? Say it again? Well, I could plug in h if I just wanted to find the volume, but what is it I want to find? I want to find the maximum volume, and that keyword maximum should tell us that we need to do something. What does the keyword maximum tell you got to do? We got to do a derivative. Okay? But I don't want to take the derivative as it sits right now. What do you suggest we do to this before we take the derivative? What? Multiply it out. Good. So I'm going to multiply these two together first and then distribute the h in. So 11 times 8.5. Somebody do that for me real quick. 93.5. All right. 11 times that. So that's minus 22h. That's 17. And then those two together, that's going to be plus 4h squared. And then I've got the h on the outside. So we're ended up with 93.5h. These two together, what is that, 39? So minus 39h squared and then plus 4h cubed. So there's my formula and I'm only dealing in h's. Okay, so let me erase some of this and move that up. All right, so there's my formula. All right, now what did we say we want to do? Take the derivative. I got b prime, so this is just going to end up being 93.5 minus 78, and then plus 12h squared. All right, so there's my derivative. Now what do I want to do with my derivative?
Plug in H.
Nope.
Do you set it equal to it?
Set it equal to what?
6
Nope. What did we do back in last semester when I wanted to find a max or a min?
0?
I set it equal to 0, because what am I interested in finding?
Oh, the biggest. The maximum.
What did you say? Critical points, because remember what happens at critical points?
Relative max,
Relative maxes and relative mins happen at critical points. So I want to set it equal to 0. I'm going to go ahead and reorder this. So 12h squared minus 78h plus 93.5. Okay, obviously I'm not going to factor that. So what are my options in going forward versus factoring? Quadratic formula. Alright, so negative b is going to be 78 plus or minus the square root of 78 squared minus 4 times a, which is 12, times c, which is 93.5. Hopefully somebody's got their calculator out getting ready to nail this. And then 2 times a, which is 24. So give me those two values of h real quick.
4.9 and 1.5.
Give me 3 decimals.
4.914.
4.914. And the other one?
1.585.
1.585. Now, look at this one. Is it possible to have a height of 4.914?
No, because it's only 8.5.
What's the biggest height you can have? 4 1/4. Okay? Because my biggest height I can have is half of this.
Wait, why?
Because if I'm cutting, I can only cut to there on both of them.
Oh, so you're looking at like you're not looking at the whole thing. You're looking like inside the cut.
Right, I can only cut. Because remember, when we wrote those formulas up, what were we doing to the height? What were we doing to the height? I wrote those formulas. We were what? What you do to the height? Doubled it. You were doubling it. So every time I doubled it. Well, if I double this, it's going to be larger than 8.5. Okay, which is not possible. My height cannot be larger than those, or double my height cannot be larger than those. So therefore, this is not an option, which means this right here is more than likely my largest volume. Now, what can I do with this number to verify it's the largest volume? Plug it in. So let's take that, somebody with their calculator, take that and plug it in right there, and then tell me what my volume is when I plug in 1.585 as my height.
Okay. So we wouldn't plug it into the derivative, right?
You're not plugging into the derivative because we are looking for volume. So when I plug that in, I should get something higher than 66.
66.148.
Oh.
Okay, so we figured out if I take an 8.5 by 11 inch sheet of paper and I cut off squares from the corner, if I want to create the figure that has the largest volume, this is how much I've got to cut off. Everybody with me?
Yes.
So what we're doing here is called optimization. Okay? Optimization means we're wanting to find a maximum, or some cases we might want to find a minimum. That's optimization. Okay? So let's talk about some things we did here that you think we're going to have to do over and over again. Find the derivative of what? Right. So we need to start out with an equation, and this equation right here is called our primary equation. And what did we eventually do to our primary equation? We took the derivative. So we always want to take the derivative of our primary equation. It's always what we want to find the maximum or minimum of. What did we want to find the maximum or minimum of? Volume. Okay? So that's why I want to do this. Now, what's the problem with our primary equation? I got too many variables. Okay? So I've got to get rid of some variables. Okay? And we knew H needed to stay because everything relied on H. So that means I needed to figure something out for L and W. What do you think those equations are called? Secondary. Okay? So then I made that substitution and I took my primary equation down to where it was one variable and I got it multiplied out. After that, then what did we do? We took the derivative and then what? Set it equal to 0 and then what? Solved it. Okay, what do we do after that? You need to plug it back in. Okay, what would have happened if I'd have plugged this in? Yeah, it'd have been jacked up. Okay, so I could have, I had you notice that before we plugged it in. I might have should just let you figure it out. Okay, but check and make sure your answers right here are usable. Okay, it was obvious that 4.914 is not usable. Okay, so figure out whether or not your answers are usable. Plug in what you've got and make sure that's your max or your min. Okay, whatever it is you're looking for. So that's the process. So step number 1. Identify your primary equation. Step number 2. Identify your secondary equation. Step 3. Substitute and reduce. 4. Derivative. 5. Set equals 0. Solve. Plug in and check your answers. That is working optimization problems. Got it? It's pretty slick. It's good stuff. Okay? We'll get into more of that tomorrow.
Is this like figures like this, or is it going to work on like a graph?
We'll do it in many different things.
Because that's just meaning for like a business.
Yeah.
Like,
Where?
Let's start with, I still get the whole why you can't have the derivative for
All right. Well, take a piece of 8.5. Take a piece of 8. Take that piece, and then try to cut off more than 4.5 inches from each corner. Measure off 5 inches from each corner, and tell me what happens.
All the time, and everyone's like, "Let's do this," because like they're all freshmen out of sophomore. I was like, "That."
Oh, he's been in the 11th time.
The short side.
What?
I can't believe it.
Hang on. Shh, quiet, please.
Will it tell you if you go to max?
Well, what do you mean? Will it tell
Will
you?
it tell you need max on it?
It won't. All right. He asked a good question. He said, will it ask for a max or a min? It might not say maximum or minimum. What could it say instead of maximum or minimum? What? Not really. Greatest. Highest. Largest. Least. Smallest. Any of those words. And you've got to know which one means maximum, which one means minimum. Quiet, please. Sometimes, sometimes not. Like this right here, I expect you to know how to find the volume of this.
So what do you think volume equals 93.5 H minus 39H?
This?
Yeah.
Now remember I had 3 little things that I multiplied all together. I figured out the formula for this and the formula for this, and I multiplied them all together, and this is what I got.
Yeah, I don't get how you get the formula for that.
Well, when you were supposed to be figuring out your volume, you should have figured out that anytime I had H, there was an H here and there was an H here, which means there were two H's. And then this whole distance is 11. So if I'm taking this away, I want to know how much is left. That's going to be 11 minus H, 11 minus 2H. Because I'm taking an H away here and I'm taking an H away here.
It was like 1/2, so it'd be 11 minus H.
What?
What you lose your H?
If this was 1/2, then yes, I plug 1/2 in here. 2 times 1/2 gives me 1. 11 minus 1 gives me 10.
The 2 comes from the 2 corners.
Yeah, there's 1 here and 1 there. So that's where the 2 comes from.
So you only look at it like that. That's the equation for.
That's what tells me. Yeah, that's what tells me the length, and then this is what tells me the
It would
width.
be like 8.5 minus 2H. Okay.
So then I put it in for these, and then I multiplied them all together, and then this is what I got.
Okay, I got it.